Looks like we do. We've got audio. That is to say, we've got microphone audio. I know we've already got video audio. All right, I'll be back in a few minutes. All right. Can pretend we're ready. Hey, folks. It's T2sday. This is the T2sday, the T2 Tile project, where we're trying to build a completely crazy, wacky, new computational stack. Most recently, using a simulated vehicle as a test bed for control. Let's check in with Beevee. You know what your problem is? Asked Slim. What's my problem? Said Beevee. You need a coach so that you can do better. And I suppose you could be that coach, is what you're saying, Slim? Well, maybe. Let's try it. See, now that's bad. Don't do that, said Slim. Uh-huh, said Beevee. So a lot of this stuff to help out Slim. So, for example, the goal here is to face to the east, head east, and then turn south and head south so you end up in the southeast corner. And BV was just going over and over again, kept turning again, and that took a long time to figure out. And then this happened. How does BV know which direction is east? By looking for the green sun in the east with the balls that happened to be in front of him. Couldn't see the sun. So this I would consider a robustness failure. And since we're saying we're trying to be a robust first model of computation, we need to pay attention to these. Here as well. I'll talk about that one afterwards. So now the drive a while mechanism, which is how we're supposed to escape when we're stuck behind balls, that wasn't working either, and that caused another infinite loop, another robustness failure, which we have to pay attention to. Do you see that? The eyes are looking into the turn. That's a good thing. I'll talk about that too. But now BV is headed west and thinks he's headed south. That would be a correctness failure. It's harder than it looks, said Slim. Uh-huh, said BV. So there it is. The goals for today, for right now, was BV should localize, meaning BV should be able to figure out where on the grid it is located at any given time and keep track of that. And we've been trying to do that for months. As you can see, all of those failures and occasional signs of progress were all in service of that. We'll see how we did. Also, I was supposed to pick a research notebook topic for the video, the next video to go, well, maybe not the next video, but the next research notebook video to go over on the Dave Ackley channel. I have decided, I might be able to change my mind, but the plan is to do a research notebook video on generalized system control. I want to take all of this stuff that I have now learned about PID controllers and this and that and the other thing, and try to put it in all in one place and a little bit of context and so on. Have more big fun. Yeah, we had a ton of fun. So for once, not for once, but for not so often, we're declaring big total green check marks for all of the goals for this month. So, that's a little weird. I wonder how that happened. All right, so I want to talk about development and then talk a little bit about planning for the second half of 2025, which is coming up awful fast. I think that this is where we're actually supposed to jump right on the second BV episode that we've got now. So let's do that and hope it's right. It does not appear to be. Uh-oh. Is it over here? No, it's nowhere. What happened? Well, this will be interesting. So now we're going to try and fix this thing up. Well, that looks like it is what it's supposed to be. So let's try that again. Crazy. BV Beevee and Slim were having fun playing around with some footage they found in the lab.
How are we going to do it? Well, in the case of Beevee, our robot, we are going to continue to try to focus on having Beevee figure out where Beevee is on the grid.
So why'd you speed him up like that, Slim?
Beevee localizes. Actually has like
That's
an
what he always does to me, said Beevee.
One little hitch. The goals for May 6th, okay, localize. You know, I am the boy who cried localize, but I feel like I'm so close.
So do you think you could do it if you wanted to? Asked Slim. Well, sure, said Beevee. It's about willpower and intention. I can do it anytime I want. You could not, said Slim. Watch, said Beevee. What's going on there? So here it is. Tick and tock, counting squares. Told ya, said Beevee. Nice, said Slim. So there it is. Yes. Well, I don't know. Is that's like 6 months or something like that. So these slides are off too. I don't know what's going on. Oh well. That's the professor finishing slides as they walk up to the podium. Behavior, results, consequences. So I want to talk about a few of the persistent problems as well as a little bit about the solutions before, we've got to go fast, before going on to the planning stage, which is just going to still have to be quick. So garden variety bugs, I had plenty of those. I've talked about them for the last several months. Then specifically correctness failures versus robustness failures. And it was kind of funny because I didn't really have it clear in my mind that there were two different kinds of things, but there kind of is. So robustness failures. The obvious case was when Beevee was trying to find east-left by looping until he saw enough green, until Beevee saw enough green to declare, this must be east. I will head in that direction. When it just, and this happened completely at random, for the first time. was close and behind two balls that completely obscured the view of the green sun, and the first time out, it just spun and spun and spun. And, an infinite loop is bad for everybody, I guess, except supposedly the infinite loop of life, the infinite loop that isn't doing any useful work. That is the robustness failure. And so I added a bunch of things. So eventually I got rid of this whole free loop and went with a little box step thing, because I try to be bottom up. I try to respect take advantage of what the world gives you. Use stigmergy. It's a term that comes up quite a bit in this kind of work. Let the terrain be its own map as much as you can. But there's also this thing saying, if you want to have exact control, if you want to know, am I on this square or I am on one square over, you basically, once you get in control, you'd like to stay in control, because once you lose it, you don't know, you may have to do a lot of work to get it back again. So that was a problem. So the solution was two parts: to use a box step so that there could be a count of how many times to turn left before saying, something's wrong. And then this other idea, a whole new thing of just drive a while in some direction. And that could in fact be random as far as anything is concerned. To hopefully get clear of whatever the obstruction is. And that worked fairly well. And then this correctness failure. Beevee thought it was heading south when in fact it was heading east. So it was counting the wrong steps. It was getting all messed up, and that was because there was a loss of control. There was at one point, and you can see it now that you know what to look for in the first episode of Beevee. There's these cases where it falls off the line and picks up another line without noticing, and so it turns from, for example, heading south to heading east without noticing. And again, so we just have to engineer those out. And here's another one where the Beevee got so close to an earth ball, and an earth ball has a bit of red in it. I didn't plan on it that way; it just kind of worked out that way, and I've been trying to live with it. In fact, Beevee smeared his left eye stalk against the thing, and got enough red in the camera that he thought he had reached the right edge and started to head south, thinking he was when in fact he was in the middle. Such things. And then just crazy bugs. This is an interesting bug, but I don't have time to talk about it. So if folks are interested, they can ask during the live stream afterwards, and I'll come back to this one. But I do want to push on to this as well. Okay. So happy. Happy. I took a selfie of myself when I finally got it working, and you can see that this is where it's positioned, 2322. Its goal is 2222. It's almost there, and I figured, maybe that could be a good title card for this episode. We shall see. All right, so I've got to finish up, and yes, so for the second half of this year, if possible, I am getting quite serious about trying to get a Ken's Torrent black hole quiet box, and they have not shipped yet, but they're saying 10 to 12 weeks out, and I have tremendous amount of nervousness about this, because I've told stories before about how unwise it is to start trying to build a software project on top of essentially experimental hardware. That's what I would be doing if I get this, but I think it's going to be cool. I think it's a lot of hardware. The black hole quiet box costs $12,000, but we have a donor to the Living Computation Foundation who is willing to fund most or all of that, which would be very, very helpful. Okay, I'm going to stop there. Next time, I want to have the second half plan confirmed, and I want to have more big fun. This month was good. I want next month to be good too. So that is it. Okay. And now let's go to the chat. Is that going to work? It looks like it works. And parameterized high FOIB high. And yeah, 0, 0. There. Now, one of the things that people notice is that Beevee's 0, 0 is not actually all the way in the southeast corner of the grid, and that's because Beevee instinctually hates being too close to the red void, because we know the risk there. If Beevee just gets spun around, like happened once in the first episode today. And Gert Tarkter, hi, thanks for speaking up. Thanks for coming by. And yeah, I know I was supposed to say tractor. So, at first I was saying, oh no, Beevee has to guess that he's like 3 squares in or 2 squares in, and set the origin to 2, 2, so that the real 0, 0 would actually be down in the corner. And then I was like, no. This localization is the localization that makes sense to Beevee. Beevee is a full self-driving vehicle. Beevee is not required to use the same coordinates as some capitalist running dog out there might choose to do. Maybe we need to find a mapping between them in the future. But it seems actually very right that, so most often, there's a little variation, but most often Beevee ends up 2 in from the lower right corner, and 2 in from the, 3 in from the upper right and lower left. So Beevee reads the size of the grid as 44 by 44, when officially it's 50 by 50. And that all seems fine to me. That seems righter to me. That, for example, if you said, I would like to go to -2, -2, Mr. Uber Beevee, Beevee would refuse to do that because it's too close to the void. You're going to have to get someone else to drive you there, and Beevee will go as far as 0, 0, and in fact the destination segment is an unsigned number. So that was a thing. And I did want to talk about, maybe I go back to the slides, right, eyes looking into the turn. So the problem that was happening here, as we saw, Beevee is supposed to head east until it gets as close to the red as it's comfortable, and then declares that to be the east edge. Turn south and do the same thing until it gets to the southern edge, and then turn west. And for a while I was doing a stair-step diagonal across the thing, but then eventually I started just saying, well, head west for the southwest corner. And but Beevee would insist on coming to the east, turning south, and then immediately heading west for the longest time, and I couldn't figure out why. And the answer turned out to be that when Beevee detects red, he's got, I keep gendering Beevee, I'm sorry. Beevee is an it. Beevee is a proud it. When Beevee detects a certain level of red, like it did by mistake when it got so close to one of the earth balls, the red level has to go then below a lower level before Beevee clears it. The system has hysteresis in it. If it reaches such a high level that it triggers the red response, then just going down a microscopic amount below that level is not enough. It has to go significantly lower in order to reset the thing so that it doesn't just jiggle at the edge. And that was really important to get the behavior good. But it meant that when Beevee turned south, it still saw red out of its left eye enough that it didn't reset the red counter. So it looked down and thought, oh my God, I am at the southern edge now, so I have to turn again. So it was doing the exact right thing. It's just not what we wanted. And so the first fix I had was a giant hack. But it was a true top-down, this will fix it. And it did. So I changed the program, the overall program that's guiding this localization process, written in NAFI, the language we talked about last time. So it comes to the east, it goes south, it turns west, goes one square, and turns south again. And because it was 180 degrees heading away from the east when it was doing that one square to the west, that's plenty to reset the red counter. And so then when it goes down, it tends to go down the third row rather than sometimes the second row, because it's going ooh, 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 like that. But it worked. And the problem is it wasted a lot of time. It's kind of stupid. And I realized that a much nicer, cleaner solution was to build bottom up. Instead of, writing more sequential code to work around something, say, wait, we have all of these sensors, some of them are parameterizable, and in particular, if we have Beevee's eye stalks pivot to look into the turn, when Beevee turns from east to south, his eye stalks will pivot to the right, which will cause the red to move out of sight. And it works. I mean, you may have seen a lot of bugs where, Beevee had cross eyes or he had jittery eyes and so forth. So getting that working as usual took a bunch of time. But now it's great. And I want to do that sort of a bottom up, use what you've got, use what makes sense. There ought to be the fact that we have all these spatial relationships in an embodied robot. This is embodied even though it's simulated, because we keep the spatial relationships consistent as much as we can. And so that was nice. And Beevee looks better making turns, just, purely on a sort of, if this was cartoon, if this was animation, you'd like to look in the direction you're turning because it makes sense. It makes sense to see where you're going, and it makes sense to not see where you're leaving. So that was pretty fun. And that was what I wanted to talk to, like that. Eye movement, yes, eye movement is NAFI, but only in a limited sense. Thank you for the question, Sci Speed. I'll come back to Gert Tractor's question afterwards. Basically, the eye stalks are controlled by Beevee's brain, are controlled by the cellular automata. There's a left eye stalk motor and a right eye stalk motor that the cellular automata can send signals down, and when they reach the Python simulation, they will ratchet the left and right eye stalks in one direction or another. To say eye movement is also NAFI is a little bit incorrect, because all of this is subsumption architecture, where as long as everything is working fine, as long as I haven't talked about grips lately, but the entire brain, Beevee's entire brain, has this small number called the grip number, which is distributed globally to the big rectangle that the whole brain is in. It's not distributed globally to the entire T2 matrix, because that sort of thing can't be done in indefinite scalability, but it goes to the entire thing where all of Beevee's brain is living. So that takes some update time, but once it's updated, everybody in that grid has easy access to what grip are we in. And as a result, hardware all over the brain can change configuration based on the grip. And so one of the grips, going all the way back to just basic Breitenberg vehicles, the follow the yellow, drive toward the yellow, which is what Beevee used to do before he got all high and mighty with looking at the grid and trying to keep track and control everything. thing. Uh, um, so the eye stalks would move under autonomous low-level control in other grips, and in particular, if Beevee gets too close to the red, he Beevee's upper level, the all of this tracking stuff that we're doing, all of this localization, driving around, picking up Uber fares, spraying, Lysol in the backseat of the car, all of that is only in tracking mode and tracking grip. And if Beevee gets so close to the red that the red warning goes off and doesn't respond to it, seems like causes the grip to change. And Beevee's tracking mode has no control over that. It's like, instinctual, low-level instincts just take over. I wanted to have Beevee scream every time Beevee goes into avoid the red mode, because it's like, ah, and you have to get far away from the red, again with the hysteresis kind of reaction, before Beevee can calm down and go back to tracking again. The problem is Beevee will have completely lost the details of what direction it's facing and where exactly it is. So eye movement is controlled by NAFI when we are in the tracking grip. And mostly it just keeps things straightforward at the moment. The eye's just sort of straight ahead. Since Beevee has downward-facing gray sensors that allow it to sense what kind of checkers, lighter, dark gray checkers, are underneath its four corners and front center, it can actually, Beevee can actually do most of this stuff without using its eye stalks at all. Its eye stalks could be like rubbernecking and looking for, oh, look, there's a yellow ball and whatnot, except in these cases, for example, in turns. I don't know too much about the structure of Beevee's mind. What kind of memory does it have, if any? So there's two kinds of memory that Beevee's got. Beevee's got sort of evolutionary memory, and Beevee's got its own lifetime memory. And the evolutionary memory of Beevee's mind is the code written in Ulam, the entire set of physics that I wrote that is constant for Beevee's entire life. Now, when I rebrain Beevee because I've hacked and rebuilt it, then that's equivalent to, okay, we're getting a whole new guy. Okay, new guy, new Beevee with a new brain, and now it's evolutionary inheritance in terms of the Ulam physics that are compiled into it has changed in a small or large way. On top of that, it's the cellular automata with, each atom, each site is a 96-bit site, of which 71 bits are user programmable by the physics. And all of that is read-write. So if there's going to be any lifetime memory, like, for example, what square am I in, and how big is the grid that I'm living in, if those are not evolutionary memory, which I've deliberately made them not be that in order to explore how can Beevee figure this stuff out without having it built in by its evolutionary ancestors, that is a classic example of Beevee's memory, and it has to be stored in the cellular automata in some particular site. If more than one place needs to know it, it has to be shipped from one to the other, or signals or something to get the information from wherever it's being stored. Like I said, with the grip, that's stored in every 3x3 group has an atom that's holding the grip number along with some other information. So it doesn't mean that it's necessarily localized, and in fact we try not to localize it, but we don't want to arbitrarily distribute information that may not be that widely necessary because there are so few bits. So we have to be stingy about representing what we want to represent and trading off with, if someplace needs this information, but they don't need it urgently, then we could build an axon. And you see all those in the brain, those lines with the flickering stuff going along them. That's what I use when I need to convey information between stuff that's not in the same X block, not in the same crossbar switch. And it's slower. Well, I mean, it depends on how far away the destination is and so forth, but it's generally notably slower than switching within an X block. It depends how big the thing is. But that's the trade-off. If so, for example, the speed and the heading and all of that stuff, all of those displays, which have been proven really useful, and I was making more and more of them over the last month as I was trying to figure out how to debug all of this. And so, all right. The problem the eye stalk moving thing solves seems a bit like target fixation in humans and other, or like a don't look down thing. Yeah, it really does. And the surprising thing for me is that I didn't implement it in order to do target fixation, or to, saying, well, it is kind of like a don't look down thing. Look away from red. Don't look away from it. I mean, in the avoid the red circumstance, the eye stalks work very differently. In fact, they move independently so that one eye can be tracking, am I still close to red? Am I still close to red? To make sure it forms a hysteresis loop to get away from the red when it's in the avoid the red grip, instead of in the tracking grid, that tracking grip that all of this stuff has been happening now. It does seem like localizing optimal grip is a good agent arena. You mean so localizing in the sense of distributing the grip to everybody, to saying that's what we're doing, and a good agent arena shared relationship. I'm not 100% sure on agent and arena what you mean there, but it sounds it sounds like something that I want to agree with. So I mean, the last point, which I didn't get to because I blabbed too long, of course, and we're past the bottom of the hour here, so I'll finish up in a couple of minutes unless there's specific thoughts or questions from folks. Getting the localization working was hard because it's hard to do this distributed computation and so forth, but also because it takes hours and hours of simulated wall clock time. I mean, it takes hours and hours of wall clock simulator time to get to the frontier. When I was debugging, so once it had successfully landed, faced east, went south, went west, went north, and I was trying to debug all the parts about having to, declare the size of the grid, pick a destination, and then go to it, and so forth. That took many hours to get there. And, to some degree, and I did do that this month, the simulator has a checkpoint mechanism that you can, that is to say the MFMS simulator, the cellular automata simulator, has a checkpoint function that you can write everything out and read it back in. It doesn't mean that it'll do the same thing it did the first time when you run forward to it, because the random numbers are not savable. But it does mean at least you can have, it already thinks it knows where it is, it already thinks, and so forth, and all of that. The problem is the Pi bullet time arena, the grid, the Beevee's physical world, does not have a checkpoint. So even though I was able to restart Beevee's brain from a checkpoint like very close to arriving at the northwest corner. The Beevee's body kept moving, so it was kind of a creepy science fiction thing from Beevee's point of view. There was like a jump cut where everything's going fine, I'm right here, and all of a sudden the body's up there. Whoa, how did that happen? Fortunately, Beevee was unaware of it because its state was all reset. Have you estimated potential speed up from using TENS torrent? There's a lot more we can do with cheaper consumer GPUs too. Again, I lean away from GPUs because of the single instruction, multiple data model that GPUs do. What we need is lots of little cores doing independent instruction streams where they can loop and branch without blocking each other. And it's just really hard to do that on a GPU. They're not designed for it. And that's why the TENS torrent architecture appealed to me. Now, there's a whole bunch of asterisks about the TENS torrent architecture. Number one is they have to target the machine learning market as well as NVIDIA and all the other ones. So what I would have liked to see is a TENS torrent chip that, much like what they did, except with much more local RAM on each core, so that I could store the physics, a complete copy of the physics on each core, so they could fetch instructions from their local core without having to go off chip to one of the RAM controllers and run into other RAM accesses like that. But the TENS torrent chips only have 1.5 megabytes per core, or per Tensix core, and so that's going to be tough. I'm not going to be able to just port the code that I'm using now. I'm going to have to build a whole new start, treating it as like a Raspberry Pi or an Arduino, or treat it as a tiny little system, and say, well, how much room can I fit in? How much space can I spend on program? How much space do I need for buffers? And so on. And then go wham. Well, now that this is the equivalent of 240 Arduinos, all tightly coupled with very fast networking between them. And so we'll see. We'll see how we can do. I haven't, well, put it this way. If I go the TENS torrent route, which again, I'm kind of leaning that way, even though I'm really scared because of, half cooked, half baked, it's going to be a very painful climb. It's going to be, for the purposes of this spike, for the purposes of the second half of 2025 anyway. Now, it may go into 2026 because I'm not sure when I will actually get, even if I ordered it now, today, and put my $12,000 down, or the foundation's $12,000 down. The sales page says 10 to 12 weeks for shipping, and I will be surprised if that turns out to be really true. You look at the issues list for Black Hole, the new card, and there's lots of issues that they're still trying to pound out before I think they're going to ship card, except to NDA insiders, that sort of thing. So my goal with this spike, with this second half, is only do stuff that is fast enough to watch it in real time. So I want to do whatever I can so that I do not have to do significant time lapse to get started. Now, maybe if I start building really big things, it will begin to slow down, and it would be good to have a little bit of time lapse so that we could show people what the system is capable of doing over the span of an hour or 2 hours, without insisting that everybody sit there and watch it for an hour and 2 hours. But it would be a couple hours sort of tops, rather than many days, which is what I've been dealing with. As the specific physics, as the specific Ulam stuff becomes more complicated and the objects I'm building become larger, everything just slows down. That's the way it works. It's like the digital light cone. And so we shall see. So I'd say the potential speed up is, the potential speed up is real time. The potential speed up is to be able to sit and watch it and go, ooh, cool. And then hopefully get big things precipitating out of this churning stuff, and get that much more headroom, so that if I can manage to re-implement Beevee's brain, say, or even go back to the Diamond replicator from 2 years ago, an actual full-on programmed cell with a copy of its code that gets both interpreted and quoted and so forth. That model, I never got past. I started into multicellularity. I got like 2-cell creatures and a couple of 4-cell creatures, but they were very rickety because they were so slow I couldn't debug them. And if we could turn that stuff, and again, I do not believe that TENS Torrent with their pitiful 1.5 megabytes of local RAM is going to be able to run anything as complicated as the Diamond replicator anytime soon. But I don't know. I mean, we have to hack our way there and find out. Then perhaps we could go back and actually start doing multicellularity more seriously and so forth, which would be extremely cool. Retractor, any general thoughts on the possibility of using biological substrates to perform computing in the future? Things like slime molds. Yeah, I mean, I know some folks, because a lot of folks, to the degree there are a lot of folks doing this anywhere, a lot of folks are in the artificial life community, which I'm kind of in and out of, and I know a fair number of people that are doing that. Yes, I think there is a general possibility of that in the future, but I think it's going to be in the pretty far future, that the distributed, robust, bottom-up, structure at all scales kind of engineering that I'm exploring using silicon is going to have to get much more better understood on its own terms before it's really, I mean, so in order to do completely general biological substrates, then that would be what I would say. But there's an asterisk, because you can take an existing biological substrate and just modify it a little bit, like, for example, sticking wires into the spine of a cockroach and driving it around using neural network stimulating the so that, driving a cockroach with a computer is arguably a biological substrate for computing. But the key that makes it possible is they're using, 99.9999% existing architecture, existing machinery, the whole cockroach, which has all of evolutionary history behind it, and then just coming in and doing a little, surgical intervention, literally, to make it do something different. And that's quite different than building stuff up from whole cloth, which is kind of what I've been trying to do. Slime molds, for example, absolutely. I mean, there's a bunch of stuff with slime molds. The challenge is getting beyond toy problems. And again, I'm still doing toy problems. If you consider Beevee a toy problem, which in some ways I do, but in some ways I don't. But usually I wouldn't try to argue the case. I will just say, yeah, it's a toy problem. It's very early. I'm like one researcher. I'm doing what I can. But the slime mold stuff, the slime mold stuff will do various kinds of relaxations and various kinds of hill climbing. And those are really important processes, really important processes, really important. They're not really algorithms in the strict sense, but, people are slopping about that these days. But to get control over that, so you can say, well, now I want to do a relaxation or a hill climb in this purpose, not just in this direction in a petri dish, but to accomplish this particular thing. to make a decision, a nonlinear decision between this and that, and go in some coordinated way. That requires a whole pile of infrastructure beyond just the slime mold. Like that. So I think that's a long ways out. I mean, it's cool research, and and I like seeing it, but I'm not waiting for it. Ryan Merritt. Hi, Ryan. Have we spoken before? This looks like a new name to me. What kind of performance is the goal for a quick simulator? Measure, yeah, in EPS. And oh, cool. Great. Well, for the longest time, I said 1 EPS, 1 AIR, AER, average event rate, is meant to be a shorthand for EPS per second. So you've got EPS per second there. So I call EPS per second AER. And so the target I was shooting for, okay. Now I have spoken to Ryan Merritt before. Well, hello again. Anyway, so again, my target since 2008 or 10, perhaps, 15 years or more, is 1 AIR. To be able to do 1 event per site per second on average over an indefinitely large grid. Now that's pretty slow. So in the sense that the MFMS simulator, as long as you only have a handful of tiles and you're running on a reasonably powerful workstation computer, conventional computer, can do dozens or hundreds of events per site per second, but that's not scalable. That's just, you've got this much hardware. As long as you keep the thing about this size, you can go fast, and the bigger you get, the slower it goes. Whereas the T2 tile grid on the wall in the other room, which we want to get Beevee's brain onto that grid, does not slow down as it gets bigger. The computation may slow down because it's doing more and more stuff over the bigger and bigger computational light cone, but the event rate doesn't change. It's still going to do 1 milliair or whatever it is. So I would like, I mean, if you're talking about, again, maybe a 100 by 100 or 1,000 by 1,000 or maybe 10,000 by 10,000 sites, something like that, I would think getting, tens or perhaps 100 AIR would be good. A lot of it depends on how complex the physics is, because unlike Conway's Game of Life, which crank it synchronously, the individual events take in different amounts of time depending on how much code there is in there. Now that's one of the things that I would be looking at. Geez, I am just yakking up a storm here. That's one of the things that I would be looking at in the black hole quiet box in the 10 storm architecture, if that's the way we go, to say, maybe we want to put a limit on how much computation time you can do for a single event. And if you go over that, we'll just declare a failure and erase the atom at the center of that event window and move on. So then it just becomes part of the architecture that everything else has to respect. We'll see. Hey, David Kiersey, slime mold, slim mold. The universe is essentially a slime mold. Well, I mean, I can agree with that. When I first glanced at that, I thought you said the university is essentially a slime mold. I can agree with that. That physics is essentially a slime mold in the sense that it relaxes to energy minima, and it's just, the energy minima in general are quite simple and obvious, sand piles and phase transitions and all that stuff notwithstanding. Even by that standard, the slime mold relaxation process is much, much more sophisticated than a much, much more conditional, much, much more fit for purpose than the sand pile cascades and so on and so forth. Okay, well, folks, geez, thank you so much for coming by and starting me up. I need questions to get me going. And you ask a question, and that stimulates ideas, and I just start talking, and I barely even know what I say. I mean, I'm trying to ride herd on it in the back. Uh, um, and so if I screw up, there's a somewhat of a chance I will catch the fact that I screwed up. But if I'm really barreling along, you'll have to tell me afterwards. Thank you, Mr. Gert Tractor. Thank you, and thank for the hearts from folks. All right, so shall we call it? Wow, 12 concurrent viewers. Hi, 12 concurrent viewers. I guess a little bit more complicated. Universe is in essentially a slime mold equilibrium information between mass and energy. Yeah, I mean, yes, and that, you know, we have both equilibrium systems and far from equilibrium systems, and the far from equilibrium systems, of course, is where the living systems are. So the equilibrium statistics will be significantly flawed unless they somehow fold in all the far from equilibrium living machinery that's out there, basically breaking down the high entropy, the high energy photons to waste heat faster and faster. You know, light. The purpose of life is to have a nice snack, as long as there's a nice snack to have. And if there's too many snacks, well, then you should think about having kids, and so forth. But yeah. Okay. Again, I'm going to call it. It's getting hot in here because I turned the air conditioning off because it's incredibly loud, but then it's still all kind of loud with the fans going in the background. Okay, well, so thank you so much, folks, for coming. Thank you for questions and comments. And again, several folks have shown up in the Discord in the last few weeks, and so I've had little chats and at least waved hi to a bunch of new folks, and that really helps me. It's in some ways a lonely business. So, working on an MFM style simulator. Yes. Okay, I am going to call it now, and hope to see folks in the Discord and here in June. Wow. Yeesh. Planets, all those things are equilibria systems at a certain space-time scale. But if you look at them at other space-time scales, they're not. They're far from equilibrium, and so forth. Okay, Ryan, aka Paging Turner. Oh, that's kind of clever. Okay, that's it. Thanks, people. Stop. Where's the... All right, here we go.